Subscribe to Emmanuel Tutorials and press the bell icon for notifications.
Hello everyone, welcome back to Emmanuel Tutorials. Today we are going to see a doubt asked by a student. This is also related to ramp signals. We have been seeing quite a lot of ramp signal examples in these days. I think that is going to help you in solving ramp signal examples easily because ramp signals are comparatively difficult to solve than unit step and other kinds of signals. Before we go into the video, if you have not subscribed to Emmanuel Tutorials yet, do subscribe to it, and to get immediate notifications, please click the bell icon next to it. Also, do like this video if you find it useful. So let's go to the video. You have to find out minus 4 r of minus 2t plus 6. So here there are a couple of operations which are being performed. First you have amplitude scaling, then you have reversal, then you have time scaling, and then you have shifting as well. So we have almost 4 operations to be performed, and we'll do that one by one. By precedence rule, you know that always time shifting is going to be performed first. Scaling, amplitude scaling can be done anytime. So first we'll do this time related operations and then we'll go to the amplitude scaling at the last because that will make our solving easier. Let's do that. Now the original signal which is being used is r of t. So before that we'll draw the original signal r of t, unit ramp signal. In unit ramp signal, what's going to happen? At 1 amplitude is 1, at 2 amplitude is 2, at 3 amplitude is 3, at 0 amplitude is 0, and so on. So this is the signal. It's going to be a slope. Now, first by precedence rule, we are going to perform time shifting. Here it is plus 6. So it is which kind? It's advanced. Advanced means you shift the signal to the left by whatever t0 is given. Here it is 6. So we'll do that. So because we are shifting it to the left, what we'll do is we'll shift the y-axis to the right a bit because that will not be needed much. We draw the axis. And this is also 1, 2, 3, 4 and so on. Now what we're going to do in time shifting, just shift the amplitudes of the signals at each of the points. So at the signal at 0 will appear as 0 minus 6. So the first point of our signal is going to be minus 6, 0 minus 6. Second point at 1, the signal is 1. So that is going to appear at 1 minus 6, which is minus 5. Signal at 2 will appear at 2 minus 6, which is minus 4. Signal at 3 will appear at 3 minus 6, which is minus 3. Signal at 4 is going to appear at 4 minus 6, which is minus 2. So I'll just shift this here. Signal at 5 will appear at 5 minus 6, which is minus 1. Signal at 6 will appear as 6 minus 6, which is 0, and so on. So the signal is going to be something like this, which is going to extend up till infinity. At 0, the amplitude is going to be 6. So we have got the shifted, time shifted signal. Now next what we're going to do, times scaling. So time scaling is by 2. Now it is multiplication by 2. So what is going to happen is signal is going to get compressed by 2. So we'll do that. Zero, 1, 2, -1, -2, -3, -4, -5. 1, 2, 3, 4, 5, 6. Now what is going to happen is signal at -6 will appear at -6 divided by 2, which is -3. Signal at -5 will appear at -5 divided by 2, which is -2.5. So here the signal is going to be 1. Similarly at -2, the signal at -4 will appear because -4 divided by 2 is -2. So amplitude is going to be 2. The signal at -3 will appear at -3 divided by 2 with amplitude 3. So it will be -1.5. The signal at -2 will appear at -1 because -2 divided by 2 is -1. And at -2 the amplitude of the signal is 4. The signal at -1 will appear at -1 by 2, which is -0.5. So the amplitude here is 5. Similarly here amplitude is going to be 5. The amplitude at 0 will appear at 0 divided by 2, which is again 0. So amplitude is going to be 6. So this is going to be the resultant signal. So you can see that the slope has changed. So when you do scaling, the slope changes. Now next we'll do time reversal. So we'll do that on this side. Reversal will be just mirroring it around the axis. Now the signal at -3 will appear at +3. So we'll just mark the points. Signal at -2 will appear at +2. So at +2 the amplitude will be +2 again. So we'll just mark those points. At 1, the signal at -1 will appear at -1. The amplitude of the signal was +4. So we'll mark that point. Similarly at 0, the signal at 0 will appear. So which is +6. So this is going to be the point. Now we'll just join these points. This is the resultant signal, which is R of -2t plus 6. Now only one operation remains, which is multiplication of the amplitude by -4. So multiplying by -4 is, first this also you can separate into two operations. Like first you multiply it by 4 and then by minus, because you just again mirror it around the x-axis. So we'll do that because that way you'll find it easier. What we'll be doing is just multiply the signal at each of the time instance, the amplitude of the signal, by 4. So we'll just mark the points a little closer so it becomes easier. So the amplitude of signal is 0 in the original signal, so it's going to be again 0 here because 0 into 4 is 0. Similarly, the signal at 2 is 2 here, so here it's going to be 8. So the amplitude will be 8 at 2. Similarly, at 1 it will be, it's 4 here, so it is going to be 4 into 4, which is 16. So the slope is going to increase a lot. You can see that it has become more steep. Okay, so the point what you can do is just draw mark the points a little closer, or you can just maybe skip some points and then show the points a little nearer so that it becomes easier for you to depict it as a diagram. Now what we'll do is the last operation, which is just multiplying it by -1. That means you just mirror it around the x-axis, similar to how you mirror around the y-axis. So mirroring around x-axis means the resultant signal will be here. So what we can do is just draw the axis on top. The points will remain as they are, 1, 2, 3, and we'll draw the axis below the x-axis. And we'll just draw it this way. So here amplitude is going to be -8 at point of -2. Similarly, next point will be -16 and so on. So if you want to show that, you can maybe take a bigger sheet size and show the points, or you can just reduce the number of points on the axis and show them closer. -4, -5, -6, -7, -8. So this will be the resultant signal. Hope you understood the way we have solved the example. If you have any doubts related to this or any other question, you could mention them in the comments of any of our videos, and we'll try to upload a video explaining that. If you found this video useful, do share it with your friends who are in need, and also like it. Do subscribe to Emmanuel Tutorials for more videos. Thank you.
Subscribe to Emmanuel Tutorials and press the bell icon for notifications.